Hello, thank you so much for visiting my YouTube channel. Let me introduce myself as Miss Malik, and I am a GCSE science teacher. I have been teaching since 2013. I've worked in a state school for 10 years, and the last 3 years I have been working as a tutor. Now, I have lots of experience in GCSE, and I do a lot of content on TikTok. If you haven't visited my TikTok, there's lots of free content on there to go through exam practice. A lot of students really do struggle with how to answer exam questions, and I'm here to help you how to understand certain questions and how to apply your knowledge to those questions. Now, this is going to be my 2025 exam series for Chemistry Paper 1. I've gone through a series of exam questions. Now, I do have predicted topics. Now, predictions may or may not come up. If they do come up, that is great. But if they don't, then do not worry about it. I do advise all students to learn all the chemistry content prior to the exams. Now, in this video, I've gone through a mixture of so many different type of questions. I've mainly gone through calculations because a lot of students do struggle with calculations. And I've gone through step-by-step methods on how to work out the calculation. So I really hope that my video does help you in terms of your revision for Chemistry Paper 1. And if you do have any comments or any questions that you would like to ask, please do leave your comments behind and I'll be more than happy to help. I really hope that my content will definitely help you. I think I've just repeated myself, but I really do hope you do really well in your exams. Good luck. I wish you best of luck and just carry on revising everything and practicing past paper exam questions. Okay, so let's get started. Okay, so I'm going to go for a topic that is called relative formula mass. Okay. Now, if you are a foundation student, you can watch this video. You may be asked to work out the relative formula mass of a compound. And if you are combined higher, you can watch as well. And if you're triple, you should already know this. So relative formula mass, it can be represented by MR as well. That stands for relative formula mass 2. Okay. Now, it is one of the most basic topics in chemistry that you need to know. And I'm going to show you how to basically work out the relative formula mass of a compound. So over here we have the formula for water, which is going to be H2O. Now we need to work out the relative formula mass. We need to work out the MR of water. So when we find hydrogen on the periodic table, now you will need your periodic table and you are given a data sheet in your exam. So this is how hydrogen would appear on the periodic table. And this top number over here is your relative atomic mass, or it's your mass number. So this is the number that you need to pay attention to. So what you're going to do, you're going to multiply that number, which is going to be 1. I'm going to just write this down. 1. You're going to multiply it by the number of atoms of hydrogen, which is going to be 2. And then we can see that we have 1 atom of oxygen. So we're going to do 1 multiply by 16, because that's the relative atomic mass for oxygen when you look at it, when you obviously find it on the periodic table. So we do 1 times by 16, and that's going to give you an answer of 18. This is how you do it. It's very simple. You just need to know the number of atoms of each element in the molecule or compound and multiply it by the relative atomic mass. So I'm going to go through another example. I'm just going to rub this out over here. So let's say, for example, if we wanted to work out the relative formula mass for this compound that we have here, which is H2SO4. So again, use your data sheet, which is a periodic table. So we've got 2 atoms of hydrogen. What I'm going to do, I'm going to write down the relative atomic masses for each of the elements. So hydrogen is going to be 1. Sulfur is going to be 32, and then oxygen is going to be 16, and they normally do give you them in the question. So we've got 2 atoms of hydrogen, so I'm going to do 2 times by the relative atomic mass, which is 1, and then we can see that we have 1 atom of sulfur, which is why we do 1 times by 32, and then we can see we've got 4 atoms of oxygen, so we do 16 times by 4. 16 is the relative atomic mass of oxygen, and that's going to give us an answer of 98. Okay, so this is how you would work out the relative formula mass, or MR, of sulfuric acid. This is H2SO4 sulfuric acid. Okay, so I'm going to go through another calculation with you, which is to do with percentage by mass. And again, this can be tested on the foundation paper and the higher paper as well. But before I do, I'm just going to show you how you basically work out the relative formula mass for this compound here. So I'm just going to rub this off here, just get rid of this, and I'm going to show you another one that we can work out. Okay, so here we have calcium hydroxide. A lot of students struggle with the one with brackets. So what we need to do is just simplify it just like you normally do in maths. So that 2 means we have 2 lots of hydrogen, 2 lots of oxygen. So if I wanted to rewrite it again, I can just do CaO2H2 in order to work out the relative formula mass. You would only do this when you're working out the relative formula mass. So remember, when we have the brackets, we just have to make sure that whatever number is outside the bracket, we times it by the number of elements that are inside the bracket, and we can see we got 1 hydrogen and we got 1 oxygen. Okay, so what we're gonna do over here, I'm gonna do 40 is the relative atomic mass for calcium. I'm sure it's 40. Gonna multiply that by 1 plus 16, which is the relative atomic mass for oxygen, multiply that by 2. And then obviously 1, which is the relative atomic mass for hydrogen, multiply that by 2, because we've got 2 atoms of hydrogen. And that is going to give us an answer of 74. Okay. A lot of students get really, well, they find it quite tricky when they see the brackets. They think, oh my God, what is this? So this is relative formula mass completed. I'm just going to rub this off over here now. Now I'm going to go on to percentage by mass. Okay, now before you can do percentage by mass, you need to know relative formula mass. So that's the basics of what you need to know. Even as a foundation student, you will need to know how to work out the relative formula mass. So let's go through percentage by element. Okay, this question does come up a lot on the foundation paper. So I'm going to write down percentage by element. Okay, right, so this is the equation that you need to familiarize yourself with. N is the number of atoms, just one moment. N is the number of atoms, times it by the AR, which is the relative atomic mass. This is going to be the MR, which is the relative formula mass, and times it by 100, okay? Right, so let's say, for example, if we want to work out the percentage by mass of sodium in sodium oxide. So this is the one that we want to work out. Sodium, Na, in Na2O. So what we need to do basically is the N is the number of atoms of sodium in sodium oxide. So we can see we have 2 atoms of sodium in sodium oxide, which we can clearly see here. So I'm going to put a 2 over there. The relative atomic mass for sodium is 23. Look on your periodic table, that's the top number, the bigger number. The relative formula mass for sodium oxide, I already know it's going to be 62. Okay, and then you multiply it by 100, and that is going to give you the answer, which is going to be 74.19%. Okay, this is going to be how you work out the percentage by mass of an element. This is the formula that you use. N is the number of atoms, times by the AR, which is the relative atomic mass, divided by the MR, which is the relative formula mass, times it by 100. Here I've got the full working out. 2 times by 23, divided by 62, times by 100, which equals 74.19%. And this is for foundation students, because this calculation may come up in your exam. Okay, so this is it for percentage by mass. If you are doing a higher paper or the triple, I'm not sure if they will ask you this question. They may or they may not. I can't promise because I don't know what's coming up on the paper, but it's worth obviously going through this calculation anyway. Okay, thank you, and I hope it helps you. Hello there everyone. The topic that I'm going to go through with you now is going to be ionic bonding, and it is to do with the dot and cross diagram. So let me read through the question with you. Sodium reacts with oxygen to produce the ionic compound sodium oxide. Oxygen is a group 6 element. Draw a dot and cross diagram to show what happens when atoms of sodium and oxygen react to produce sodium oxide. And this is worth 4 marks. Now, as you can already see, I already have 2 atoms of sodium already drawn and 1 atom for oxygen. But you may be thinking, why have I got 2 atoms of sodium and 1 atom of oxygen? So the first thing that you need to do is that you need to know what is the molecular formula for sodium oxide. So when we're working out the molecular formula, what we need to do is that we need to know the charge for each element. So I know that sodium is in group 1 of the periodic table, and sodium is a metal and it is positively charged. But just remember that the group does not determine the charge for the element. Oxygen has a charge of 2 minus, which I'm going to show you over here. So we just need to work out the formula of sodium oxide, and we're going to use the charges to work out the formula. Now, I have a really easy method on how to do this. You may have been taught it a bit different in school, but I have an easier way of understanding this. All I do is I just swap the numbers around. So that plus over there, which is near sodium, is going to be +1. This is going to go over here, and the 2 minus is going to go over there. Now, when you're rewriting the formula, when you're writing it out, you don't have to include the charges. So it's simply going to be Na2O. So that 2 from oxygen went to sodium, and that 1 from sodium went to oxygen. And that is your formula for sodium oxide. And that is the easiest way that you could do it. So now we have established that why we got 2 atoms of sodium and 1 for oxygen, we need to draw the dot and cross diagram. So I'm just going to get rid of this over here. Okay, so I know that sodium has a total of 11 electrons. So what I'm going to do is I'm going to draw the electrons on the shells. I'm going to draw them as dots. So the first shell can only have up to 2, which I'm going to show you here. So top, bottom. And then the second shell can have a maximum of 8. Top, bottom, right, left. Top, bottom, right, and left. So far we have got 10 electrons drawn. We know it has a total of 11. So the last electron is going to be in the outermost shell over here. Okay, right. Now I'm going to do the same for this sodium atom over here. Just the same as what I did to the one on the right. Just going to draw the electrons very quickly. I always draw the electrons as top, bottom, right, left. I just think it makes it much more easier to remember. Now oxygen is in group 6 of the periodic table, and oxygen has a total of 8 electrons. So in the first shell we know it can only have 2. So I'm going to draw crosses here just to distinguish between sodium and oxygen. So 1 cross there and 1 there. Now in the second shell we know we can have a maximum of 8, but we've already drawn 2 in the first shell. So let's draw 6 in the second shell, because that will total to 8 electrons. Top, bottom, right, left. top, bottom. I've stopped now because oxygen has a total of 8 electrons. Please make sure that you use your periodic table. You will be given a data sheet. Right, okay, so we need to draw a dot and crest diagram to show what happens when atoms of sodium and oxygen react to produce sodium oxide. This is the part where it gets a little bit tricky, but we know that metals are positively charged and they lose electrons, and non-metals gain electrons. So what's pretty much going to happen is that this electron, which is for this sodium atom on the left, it's going to go over here. And it's going to, just one moment, I'm going to change the colour. It's going to join here on the outermost shell for oxygen. And the same for this one over here. It's going to go over there. Now we can see that oxygen has a full outer shell. Because it's got a full outer shell of electrons, it's now become an ion. So it goes from being an atom to an ion. So I'm going to draw the structure for the ion for oxygen, which is going to be over here. Just bear with me, just want to make sure I do it perfectly. So here we are. And okay, so we can see that we have over here, I'm just going to change the thickness. And we can see here oxygen has a full outer shell and it has actually become an ion. We have to include the brackets when it becomes an ion. And here it is, it's complete. And you have to have the charge outside the bracket. This is how you would have learned it in school. And this is how we teach it the same everywhere. So over here, oxygen is an atom where I'm pointing to. And then it goes on to being an ion. Okay, so an ion is a charged particle that's produced by the loss or gain of electrons. So let's draw the ions for sodium. So I'm going to do that right now here. Just one moment. So for sodium, one moment. And just going to get rid of that. So let me finish this off. Na, and I'm going to draw the electrons over here. We can see that sodium now has a full outer shell of electrons. It's lost one electron and it's got a full outer shell over here. And also we need to include the brackets as well, along with the charge outside the bracket. And the charge for sodium is going to be +1. Okay, and then I just do the same over here as well, which I'm going to show you. So just another sodium ion. These are ions now, remember they're not atoms. And then over here, do the brackets, put +1, that's going to be Na. And then here we just draw everything. Which you can see I've done over here. I'm just going to use a different colour. So yeah, that's better. This is all you need to do for this question. So you just need to draw a dot and crest diagram to show what happens when atoms of sodium and oxygen react to produce sodium oxide. So here at the top are the atoms, and this is how they become ions. Okay, so this will get you a full 4 marks. This is a very popular question that does come up. It is a predicted topic. It may or may not come up, but at least you know how to do it now. And I really hope it has been very helpful. And I'm going to go on to the next topic now. Hello everyone, I'm going to go through an exam question to do with allotropes of carbon, and we're going to look at one in particular, which is going to be graphite, which is a 6-mark question. Figure 3 represents the structure of graphite. Explain why graphite is a good electrical conductor and soft and slippery. You should answer in terms of structure and bonding. So firstly, when we look at figure 3, we can clearly see that graphite is made of repeating hexagons. And also we can see that each carbon atom, which I'm going to highlight over here, it has one double bond and it has 2 single bonds as well. And also we can see each carbon atom over here, which I'm going to highlight blue, it is bonded to 3 other carbon atoms, which I've labeled as 1, 2, and 3. Okay, so let's put this into writing. The first thing that I have wrote is that bonds are covalent and giant structure. You can also write down it has a giant macromolecular structure as well. And I've wrote down 3 covalent bonds per carbon atom, which I've already showed you. So 1 electron per carbon atom is delocalized. These delocalized electrons can move through the structure, carrying an electrical charge. So graphite conducts electricity. Now I've also mentioned that there are no covalent bonds between the layers. So the layers can slide over each other, which makes graphite soft and slippery. Okay, now this is my model answer so far, and this will get you 6 marks, but just remember, because the hexagons are flat, graphite can form sheets which stack in layers, and these layers can slide over each other, making the substance soft and slippery. So graphite also has electrons which are delocalized, which are free to move around and carry a charge, and this means graphite can conduct electricity. I really hope that this exam question and my model answer has helped you to understand the reason why graphite is a good electrical conductor and soft and slippery. Okay, thank you. Hello everyone, I'm going to go for a topic that is atomic structure. According to the examiner report, a lot of students do get these questions wrong, and they are quite simple, but let me close any gaps in your learning. Question 2.1. This question is about atomic structure and a periodic table. Gallium is an element that has 2 isotopes. Give the meaning of isotopes, and you should answer in terms of subatomic particles. What are subatomic particles? They are protons, neutrons, and electrons. So here is my model answer. Same number of protons but different number of neutrons. That will get you 2 marks. You are allowed to also write down it has the same atomic number but different number of neutrons. That would also get you 2 marks. If you write down it has a different mass number, you will not get the mark. So what I've written down over here it is your model answer, and I would advise you to memorize it like this. Right, let's go through question 2.2. Table 1 shows the mass numbers and percentage abundances of the isotopes of gallium. This question is getting very popular, and it does come up on the triple chemistry paper quite a lot. So it wants you to calculate the relative atomic mass of gallium, give your answer to 1 decimal place. Right, all you need to do is that you need to basically, I'm just going to enable my highlighter. So here we have the mass number, which I've highlighted yellow. You're going to multiply that by the percentage abundance, which I've highlighted again yellow. And then you do the same for the other one, which is 71. You're going to multiply that by 40. So you can see I've already wrote the I've already got the working out, over here. So 69 multiplied by 60, put it in brackets, plus 71 times by 40. Then you divide it by 100 to get the answer, and that's going to give you 69.8. And this calculation is so easy. It can be worth 2 or 3 marks, but believe it or not, a lot of students get this question wrong because they just don't know how to do it basically, and how to work it out. So this is how you work it out. And I can assure you that you'll probably get a question like this on your chemistry triple paper. Right, I really hope that this has helped you. And yeah, I'm going to move on to the next video. Hello everyone, I'm going to go through an exam question based on group 1 elements. Right, so 4.1, give 2 observations you can make when a small piece of potassium is added to water. So you can see I wrote down single words and that would qualify for 2 marks. Right, so I wrote down that it floats, which will get me 1 mark, and I've also wrote down that it melts as well. You can also write down that the potassium moves around. You can also write that potassium becomes smaller, it has a lilac flame. Potassium disappears, and you can write down fizzing as well, and that will get you the 2 marks. Complete the equation for the reaction of potassium with water. So you need to be really good at balancing equations. So when you react potassium with water, so let me show you over here. Here we have potassium and it's going to react with water. It is going to basically give you potassium hydroxide, which I'm going to write over here. Okay, KOH. K is the symbol for potassium and OH is going to be for hydroxide. And then we get hydrogen gas, which I'm going to write over here. So you need to also balance the equation. So when we balance the equations, we have to divide it into reactants and then the products. We always look at the first element in the equation. So I can see that potassium, it has 1 atom of potassium on the reactant side. We've got 1 on the product side. That's fine. So I can see that I've got 2 hydrogens on the reactant side, but I've got 3 on the product side. So what am I going to do? I am going to put a 2 over here in front of potassium hydroxide. So that's giving me 2 hydrogens there and 2 there. So we've got 4 on this side. So I'm just going to put a 2 over here. So 2 multiplied by 2 is going to give me 4 here. So I've got equal number of hydrogens on both sides. But I've also got 2 potassiums as well. So I'm going to put a 2 over here on the reactant side. That 2, which is in front of KOH, represents the potassium and the oxygen and hydrogen. So you can see basically that I've put a 2 in front of H2O, which gives us 4 hydrogens and 2 oxygens. And here is your balanced equation, 2, 2, 2. And it is the same for each of the elements in group 1 elements, and that will get you 2 marks over here. The next question is to do with the reactivity, the trend in the reactivity of group 1 elements. So explain why the reactivity of elements changes going down the group. So we know that the reactivity increases as we go down the group. So the reason it increases is because the outer electron is further away from the nucleus. So there is going to be less attraction between the nucleus and the outer electron. So the atom loses an electron more easily, and that is going to get you the full 4 marks. Okay. So this is it for now for group 1 elements, and I really hope it has been very useful for you. Hello there everyone, I'm going to go through a chemistry calculation with you that may come up in your exam. So let's go through question 3.1. This question is about the extraction of metals. Element R is extracted from its oxide by reduction with hydrogen. The equation for the reaction is below. The sum of all the relative formula masses of the reactant side is going to be 150. So we can write down here, that's the reactant side, and that's going to be 150. It wants you to calculate the relative atomic mass of R, which is the unknown on the product side. So that is what we need to work out. So what we need to do first is we need to work out the relative formula mass of water. I have already worked it out, and I think it's going to, it is 54. I've already calculated this already. So all we have to do is 150 take away 54, and that's going to give us an answer of 96. Okay. So that is the relative atomic mass for the element R. So now 3.2, identify element R. You will use your periodic table for this. I've already wrote down the answer. The periodic table will be the data sheet that you are given in your exam, and it's going to be molybdenum. Okay, so I hope you have found this very useful, and let's move on to the next calculation. Hello everyone, I'm going to go through a calculation based on the topic atom economy. It is one of my predictions for chemistry paper 1, and this is for triple chemistry. Right, let's go through question 3.3. Carbon is used to extract tin from tin oxide. The equation for the reaction is below. Calculate the percentage atom economy for extracting tin in this reaction. So the first thing that we need to establish is that we need to know what is the equation. Now, you're not given this equation in your exam. You need to memorize it. So when you work out the atom economy, you do the MR of the desired product divided by the total MR of all the reactants, and then you multiply it by 100 to get it into a percentage. Now, you might be thinking, what is the desired product? So the desired product is going to be tin. So I'm just going to highlight it over here. It mentions here, calculate the percentage atom economy for extracting tin. So that is going to be your, just one moment, your desired product, okay? I'm going to write that down over here. Okay, so now we know that the desired product is going to be tin. I'm going to put 119 over here. And then we have to divide it by the total MR of all the reactants. So the reactant side is over here, which I've just underlined. I'm going to write it here. That's your reactant side. You are already given the relative atomic masses for tin, which is represented by the symbol Sn, and then oxygen and carbon. So all you have to do is multiply it by the number of atoms in the formula that we have here. So that is going to give you a total of 163, the relative formula mass. So you do 119 divided by 163, multiply it by 100, and that's going to give you 73%, okay? I haven't gone through with you how to work out the relative formula mass because I've done a separate video on that you should have watched earlier on. But when you work out the relative formula mass, you need to make sure that you multiply the relative atomic masses by the number of atoms in the molecule that you can see, okay? So this is atom economy, and it is worth 3 marks, and it is one of my predictions that I think may or may not come up. Okay, I'm going to move on to the next chemistry calculation. Hello there, I'm going to go through an exam question based on ionic compounds. So let's go through question 4.5. Why is oxygen described as being reduced in a reaction between sodium and oxygen? So it mentions a key word here, which is reduced. And we know the opposite of reduced is going to be oxidized. So you must have heard of oil rig over here. So oil stands for oxidation is loss, and then rig stands for reduction is gain. So reduced is going to be associated with rig. So we know that oxygen is going to gain electrons, okay? Just one moment, I'm just going to write that down. So that is the reason why oxygen is described as being reduced in a reaction between sodium and oxygen, because it gains electrons, and that will get you 1 mark. Right, let's go through question 4.6. And a lot of students really do struggle with this type of question. Explain why sodium oxide has a high melting point. Now, sodium oxide is actually an ionic compound, okay? So it's very important for you to know what are the properties of ionic compounds, because this is what this question is asking you. So we can see that sodium oxide has it has a giant structure, so that would basically get you 1 mark. Giant structure, and it has very strong electrostatic forces of attraction between oppositely charged ions, which is between the positive and the negative. That's what we mean by electrostatic forces of attraction. It's very important for you to mention this point as well to qualify for the 2nd mark. Therefore, large amounts of energy are needed to break all the bonds, and that over here is going to get you the 3rd mark. And this is my model answer of why sodium oxide has a high melting point. They may ask you, why does potassium oxide have a high melting point? You'd write the same answer like this, because potassium oxide is also an ionic compound. Now remember, ionic compound is when a metal and a non-metal react together. Okay, so I hope this has really helped you, and I am going to move on to the next video. Hello there everyone, I'm going to go through a chemistry calculation based on calculating gas volumes, and this is for triple chemistry, and this question did come up on last year's paper and it may come up again. So let's go through the exam question. Iron chloride is produced by heating iron in chlorine gas. The equation for the reaction is written below. Calculate the volume of chlorine needed to react with 14 grams of iron. You should calculate the number of moles of iron used, the number of moles of chlorine that react with 14 grams of iron, and the volume of chlorine needed. Okay, so I'm going to go for a really easy method on how to do this. Okay, because the last thing that you want to do in your exam is to stress, and you don't want too many steps involved because it can make it very confusing. So the good thing about this question is that they've actually given you bullet points, and I would do it according to the bullet points. So I would divide your calculation into 3 parts. But I just want to quickly go through these equations below that I have over here. Now we need to work out the volume. In order for us to work out the volume, we need the amount of gas, the moles. So before we can even work out the volume, we need the moles, and that's the first thing we're going to do, is work out the number of moles by dividing the mass by the RAM. So in this question, we can see that we have already been given the mass of iron. So we're going to work out the number of moles of iron. So that's the first thing that I am actually going to do over here. So I'm going to show you what I'm going to do. So moles equal, do 14 grams, which is the mass of iron. I'm going to divide that by 56 because that's the relative atomic mass for iron. And that is going to give me 0.25 moles. That's going to be your answer. So what I'm going to do, I'm just going to tick this part over here because we've already done it, and I would advise you to do that in your exam as well. Now we need to work out the number of moles of chlorine that react with 14 grams of iron. So all we have to do over here is we can see that we have a 3 over here and a 2 over there. So what we're going to do is when we're working out the number of moles of chlorine, let me show you. Moles of chlorine is going to be the 3 divided by the 2 and then times it by the 0.25, and that's going to give you 0.375. So what you've just done here to work out the moles of chlorine, you've done the 3, you've divided it by the 2, which is the coefficient obviously, which is the 3, then divided it by 2, and then you multiplied it by 0.25 by the value that we got here at the start. Okay, so that is now the number of moles of chlorine that react with 14 grams of iron. And you would do the same in every other question, just to let you know. Okay, now we're going to do the last part, which is where we're going to work out the volume of chlorine needed. So in order for us to work out the volume, we need the amount of gas in moles, and that's going to be 0.375. We're going to multiply that by 24 decimeter cube because we got that from over here, and that is going to give you an answer of, so volume of chlorine is going to be 9 decimeter cube. That's going to be your answer, and that is it. That's all you need to do. So can you just see how we have split this calculation into 3 parts? Now, it's not the same for every question. Sometimes they don't split it up into bullet points. They will expect you to know all of this method. So what I would advise you to do is follow my method, practice another exam question like this. If you follow my method, I can promise you that you will get the right answer. I really hope this has helped. Please do leave your comments if there's anything that you are unsure about, and I'll be more than happy to help you. But this calculation is only for triple chemistry, and it is a very popular calculation. I have seen it come up very often, and it's very important for you to know how to do this calculation. Please follow my 3 steps over here. It will definitely get you full marks, and please memorize these equations because you're not going to be given them in your exam. Okay, thank you. Okay there, so I'm going to go through a chemistry calculation, and this sort of calculation has come up on previous past papers, and a lot of students do not know how to do this calculation, but I'm going to show you how easy it is. So let's go through question 9.4. I'm just going to zoom in a little bit. Okay, I think that's better. So ethylene dioic acid is a solid at room temperature. Calculate the mass of ethylene dioic acid needed to make 250 centimeter cube of a solution with concentration of 0.0480. And here we have been given the relative formula mass of the ethylene dioic acid. So the first equation that we're going to use is this one over here, which is number of moles represented by the N equals the concentration times by the volume. So in order for us to work out the mass, we need the number of moles. Now, when we work out the number of moles, we can see that the concentration is over here, which is 0.0480. So I'm going to put that number into the equation. And then we need to multiply it by the volume. The volume needs to be in decimeter cube. So when you convert from centimeter cube into decimeter cube, you divide it by 1,000. So you do 250, divide it by 1,000, it's going to give you 0.25. Now we've worked out the number of moles, and that is going to give us 0.012. Now we can work out the mass. When we are working out the mass, I'm just going to write this over here. Mass equals moles multiplied by the RFM. We're going to multiply it by the RFM of the ethylene dioic acid. So the number of moles is 0.012 multiplied by 90, because that is the RFM of the ethylene dioic acid, because we need to work out the mass of ethylene dioic acid. Okay, so that is going to give us an answer 1.08, and that is going to give you 2 marks. Okay, so this is how you would work out the answer to this question over here. The next question that I'm going to do is going to be based on a titration calculation. This one is worth 3 marks. Now, the titration calculation did not come up in chemistry paper 1, which was a 2024 paper. It didn't come up last year, and I do have a feeling that it will come up this year. So I'm going to show you my 4-step method on how to do this calculation. So this is going to be the next video. Hello there everyone, I'm going to go through the titration calculation. Now this calculation did not come up last year, it may come up this year. I do have a feeling that it will come up. Now I have an easy 4-step method to help you with this calculation. So as you can see, I've wrote down the 4-step method at the top. So I've written down equation for number 1, number 2, moles of the known concentration, number 3, molar ratio, and number 3, calculate the concentration. Now in a titration calculation, you will always be asked to calculate the concentration. Right, so what we're going to do first, we're going to do this step by step. Now, with the equation, I always tell students to take highlighters into the exam. It just makes it very easy to understand things and not to make mistakes. So let me read through the question with you. The student found that 25 centimeter cube of the sodium hydroxide solution was neutralized by 15 centimeter cube of the 0.0480 moles per decimeter cube ethylene dioic acid solution. Okay, so firstly, this is ethylene dioic acid. I'm just going to basically highlight it over here. Sorry for that. This is the ethylene dioic acid. And then over here, we have the sodium hydroxide solution, which I'm going to highlight over here. It's just good to do this in your exam so you don't make any mistakes. Okay, so the first thing we have to do is the first part we've already done, which is the equation. Just highlight the important substances that it mentions in the question. So I'm just going to tick this part over here that we've done that, okay? Now let's work out the moles of the known concentration. So in order for us to work out the concentration, we need the number of moles. So this is the equation that you are going to use. N equals concentration times by volume. Okay, so what we're going to do basically is we are going to work out the number of moles of the known concentration. So we have been given the concentration of ethylene dioic acid. So what I'm going to do is I'm going to write down over here 0.0480 multiplied by the volume of ethylene dioic acid. You can see that I've already converted the volume into decimeter cube, and I would advise you to do that as well at the beginning of the question. So the volume is going to be 0.015 for ethylene dioic acid. I'm going to write that over here. the reason it's 0.015 because we need to get it converted into decimeter cube from centimeter cube. So this is the first part, and the answer that we are going to get over here, so let me just work out 0.0480 multiplied by 0.015, and we're going to get this really long decimal, which is going to be 0.00072 moles. Okay, now we have worked out the moles of the known concentration, so I'm going to tick this part over here. Now we need to work out the molar ratio of ethanoic acid and sodium hydroxide. So the molar ratio we can see is 1 to 2, which we can clearly see, and I've just wrote it down over here. So what we're going to do with the number of moles of ethanoic acid, we're going to multiply it by 2. So I'm going to do this over here. Just one moment, sorry. So number 3, molar ratio, I'm going to do 0.00072, multiply it by 2 to get the answer, which is going to give me 0.00144. Now that is the number of moles of sodium hydroxide solution. Now we can work out the concentration. Okay, so I'll just quickly talk you through what we've done. We've worked out the moles of the known concentration, which is for ethanoic acid, which is 0.00072. Now we had to work out the moles. Obviously, where we look at the molar ratio, we can see it's 1 to 2. So we multiplied the number of moles of ethanoic acid by 2 to get the number of moles for sodium hydroxide solution, which is going to be 0.0144 moles. So we've done the molar ratio part. We've completed the calculation nearly. We need to work out the concentration. So again, we're going to use the same equation over here, which is going to be number of moles equals concentration times by the volume. The number of moles we have over here, which is 0.00144 equals the concentration is what we need to work out, and then obviously the volume is basically 0.025. So as we normally do, we're going to divide both sides by 0.025 to get concentration on its own. And then we can see I've cancelled it out. We do 0.00. I'm going to work out the answer now. I've got my calculator with me. Divide that by 0.025, and that's going to give us an answer of 0.0576, and that is going to basically be your answer. Okay, so this is how you would use my 4-step method in order to work out this calculation. I really hope you have found it useful. If you do have any comments, do leave them behind. Okay everyone, I'm going to go through another titration calculation, and this one is worth 6 marks. Now as you can see, I've already done the full working out because it is quite a long calculation, but I will go through each step with you. So let's go through the question. The student repeated the investigation. The student used solutions that had different concentrations from the first investigation. The student found that 15.5 centimeter cube or 0.500 moles per decimeter cube of dilute sulfuric acid completely reacted with 25 centimeter cube of potassium hydroxide solution. The equation for the reaction is below. Calculate the concentration of the potassium hydroxide solution in moles per decimeter cube and in grams per decimeter cube. Now, you do not need to worry about grams per decimeter cube towards the very end. So the first thing that you need to do is that we need to highlight the equation. So you can see at this part over here, I have highlighted the potassium hydroxide and solution and obviously sulfuric acid. So that's the first part of the calculation, where we obviously have to highlight the important substances that are involved in the reaction, which I've done. So that is the equation. Now step 2, we need to work out the moles of the known concentration. So we have the concentration for dilute sulfuric acid, and we know that the volume for dilute sulfuric acid is 15.5 centimeter cube, but that needs to be in decimeter cube. So you can see over here, I've done 15.5 divided by 1,000 gives us 0.0155. So that is now in decimeter cube. Okay. Okay, so now I've done the concentration, which is 0.500, times it by 0.0155, and then that's going to give me the answer 0.00775 moles of sulfuric acid. Okay, so now we've worked out the number of moles of sulfuric acid. Now we're going to do step 3, which is going to be the molar ratio. So we look at the molar ratio of potassium hydroxide to sulfuric acid. We can see that it is 2 to 1. You can see it's 2 over here. I've just underlined it, and then 1 there. So then what we do is we are going to multiply the number of moles of sulfuric acid by 2 to get the number of moles of potassium hydroxide, which you can see I've done over here in step 3. So I'll do 0.00775 times by 2, which gives me 0.0155 moles of potassium hydroxide. Now I can work out the concentration, and that is step 4. When we work out the concentration, we do the number of moles, which is 0.015, which we got from the previous part of the calculation. We divide it by the volume of potassium hydroxide solution, which is going to be 0.025. It says 25 centimeter cube over here, but we had to convert it into decimeter cube, which makes it 0.025. And then we get the answer 0.62. So that is going to be our answer in moles per decimeter cube. Now it's also asking you for the final mark to give the answer in grams per decimeter cube. So that's very simple. All you have to do is for moles per decimeter cube, where I've underlined it, we convert it from moles per decimeter cube into grams per decimeter cube. You have to multiply it by the molar mass of potassium hydroxide. And the molar mass of potassium hydroxide, KOH, is going to be 56. It's just like working out the RFM. And then we do 0.62, multiply it by 56, and that's going to give us the concentration in grams per decimeter cube, which is going to be 34.7. This is a full 6-mark question. Now, if you don't write down the concentration in grams per decimeter cube, you'll probably get 5 marks. But it's very important for you to know how to do this. This is one of my predicted topics that I think may come up in Chemistry Paper 1. I've gone through the full working out with you. If you do have any questions to ask, please feel free to leave a comment. Thank you. Okay, so this calculation is going to be about limiting reactants, and I'm going to show you a step-by-step method on how to do this. This is one of my predictions for Chemistry Paper 1 triple. So let's go through the exam question. 6.2. A mixture contains 1 kilogram of aluminium and 3 kilograms of iron oxide. The equation for the reaction is written below. Show that aluminium is the limiting reactant. So we know that aluminium is the limiting reactant, but we need to show the examiner by doing a calculation as to why aluminium is the limiting reactant. So that's where you have to do the calculation below. Okay, so the first thing you need to take into account that it needs to be in grams. Okay, so that 1 kilogram is going to be 1,000 grams. It always needs to be in grams, and over here that's going to be 3,000 grams. Okay, so that's the first part that we need to do in terms of the calculation. Now what we're going to do now is that we're going to work out the number of moles of aluminium and iron oxide. So let's start with aluminium over here. We're working out the number of moles. Moles equals the mass divided by the relative atomic mass. Okay, so the mass for aluminium is going to be 1,000. I'm going to divide that by the relative atomic mass of aluminium, and that's going to be 27. You don't multiply that 27 by the 2, the coefficient, when it comes to limiting reactants. And that's going to give me an answer of 37 moles. Okay, now we work the number of moles of aluminium. Now we're going to work out the number of moles of iron oxide. Okay, so let's do this next. And the number of moles is going to be just one moment, bear with me. Just want to make sure I structure it the right way. So moles equals, again, mass divided by the relative atomic mass. So we do 3,000 divided by the relative atomic mass of iron. But it's a relative formula mass because we can see we've got 2 atoms of iron and 3 of oxygen. So that is going to be 160. And that's going to give me an answer of 18.75 moles, okay? This is the first step where you're working out the number of moles for aluminium and iron oxide. Now, the second step, there's two steps to this calculation. The first step is working out the number of moles. The second step is basically dividing it by the coefficient, okay? So I'm going to show you what we're going to do. So this is going to be divide by the coefficient, which is the big numbers over here, which we got 2 for aluminium, and then we got obviously 1 for iron oxide, okay? So what we're going to do, we're going to divide, let's do for aluminium first. So let's do aluminium over here. So we're going to do 37, divide it by 2, and that's going to give us an answer of 18.5. And then when we do it for aluminium, sorry, not aluminium, iron oxide, we're going to do basically 18.75 divided by 1, and it's going to give us 18.75. Sorry about that. So now we can see that aluminium is the limiting reactant because it's the lowest number. So that here is your limiting reactant. So whichever is the lowest number is the limiting reactant. It's not going to be iron oxide because you can see it comes out with 18.75, and 18.5 is lower than 18.75, hence why aluminium is the limiting reactant. So whichever is the lowest number, that is going to be your limiting reactant. And this full method will get you 4 marks. I really hope you understand limiting reactants. If you do have any questions, anything that you'd like to ask, please do leave it in the comments and I'll be more than happy to help you. Hello there, I'm going to go through an exam question based on structure and bonding. So let's go through question 1.1. So which two substances have intermolecular forces between the particles? So I've already ticked the correct answers and it's going to be polyethylene and water. Remember, intermolecular forces are between non-metals, okay? Now, covalent bonds are found between the atoms. Just remember that. And weak intermolecular forces are between the molecules. Table 1 shows the structure of 3 compounds. Compare the structure and bonding of the 3 compounds of carbon dioxide, magnesium oxide, and silicon dioxide. So let's start off with carbon dioxide. So carbon dioxide and silicon dioxide are made up of atoms, whereas magnesium oxide is made up of ions. Magnesium oxide is actually an ionic compound, okay? So magnesium oxide is an ionic compound. I'm just going to write it there. And it's to do with ionic bonding, where electrons are being transferred, they're not being shared, okay? And obviously with ionic bonding, it involves ions, not atoms. So all 3 compounds have strong bonds. Carbon dioxide and silicon dioxide are formed from 2 non-metals, which is correct. And the bonds formed are covalent, so electrons are shared, because in covalent bonding, electrons are shared. Magnesium oxide is formed from a metal and a non-metal. So the bonds in magnesium oxide are ionic, and 2 electrons are transferred from magnesium to oxygen. And that is to do with ionic bonding. Now, the bonds in silicon dioxide are single bonds. So in silicon dioxide, which we can see the structure here, there are single bonds, and we can see that each silicon atom is bonded to 4 other carbon atoms. So we can see we got 1 over there, 2, 3, and 4. So make sure you do use these diagrams to help you with writing your answer. So I wrote down over here, the bonds in silicon dioxide are single bonds, where each silicon forms 4 bonds and each oxygen forms 2 bonds. In carbon dioxide, the bonds are double bonds. So we can see we've got 1 double bond here, the second one over here. This is a double bond. You can state that as part of your answer. And so in carbon dioxide, the bonds are double bonds, where carbon forms 2 double bonds and oxygen forms 1 double bond, okay? Which I will show you over here, okay? So just make sure you make use of these diagrams to basically help you. So carbon obviously has 2 double bonds, and oxygen, you can see in the key, will have 1 double bond. Okay. Both bonds in silicon dioxide are single bonds, where each silicon forms 4 bonds and each oxygen forms 2 bonds. carbon forms 2 double bonds, and oxygen forms 1 double bond. Okay, this here is going to be your model answer to get 6 marks. And I've got the full answer over here that will qualify for full marks. And this is to do with structure and bonding. We can see that we have 3 different types of compounds. Over here we have carbon dioxide, which is a simple molecule, and then magnesium oxide and silicon dioxide. Okay, I really hope that this has helped you, and I'm going to move on to the next question. Okay, I'm going to go for a past paper exam question for chemistry paper 1. So let me read through the question with you. This question is about silver iodide. The silver iodide is produced in a reaction between silver nitrate solution and sodium iodide solution. The equation for the reaction is below. A student investigated the law of conservation of mass. This is the method that they use. Pour silver nitrate solution into beaker labeled A. Pour sodium iodide solution into beaker labeled B. Measure the masses of both beakers and their contents. Pour the solution from beaker B into beaker A. And measure the masses of both beakers and their contents again. And table 3 shows the results over here. Okay, so explain how the results demonstrate the law of conservation of mass. You should use data from table 3 in your answer. So it tells us in the question, where we look at step 4, it says pour the solution from beaker B into beaker A. Okay, so we can see that the mass before mixing over here is going to be 156.76, and that's going to be before mixing. And then after mixing, it is still going to be 156.76. So you do 78.26 plus 78.50, and then over here we do 108.22 plus 48.54. So what we can write that, if you do this calculation over here, which I've just done over here, so if you did 78.26 plus 78.50, which gives you 156.76, and then this is going to be mass before, and then mass after. You just do 108.22 plus 48.54, and that's going to give you 156.7. Oh, sorry, let me just rewrite that again. Just one moment. 156.76. That's supposed to be a 6 there. So what you can write down at the end is that there is no change in mass during the reaction. That'll get you a 2nd mark. There is no change in mass during the reaction. Okay, so this will get you 2 marks, and this is how the results demonstrate the law of conservation. Okay, right, the next part of this question is 3.2. It suggests how the student could separate the insoluble silver iodide from the mixture at the end of the reaction. And you can just write down, you can filter it, you can filtrate it. I'm going to write down filter. That will get us the mark. And then the student purified the separated silver iodide. This is the method that they use. Rinse the silver iodide with distilled water. Warm the silver iodide. Suggest one impurity that was removed by rinsing with water. And the impurity would be basically sodium nitrate, or you can write down silver nitrate or sodium iodide. So I'm going to write down here for 3.3 sodium nitrate. That was the impurity that was removed by rinsing it with water. Okay, so just why the student warmed the silver iodide. The reason why the student would have warmed it is just to evaporate the water that was in there. Evaporate the water. Okay, this is again on atom economy. I've got a full working out over here. Calculate the percentage atom economy for the production of silver iodide in the reaction. So silver iodide is basically going to be the desired product. And it's going to be over here. This is silver iodide. This is going to be your desired product. So you do the total MR of the desired product, which is going to be 235, divided by the total MR of all the reactants, which is going to be 320, times it by 100, and that gives you 73.4%. This is worth 4 marks, and it is one of my predictions for chemistry paper 1. 3.6, give one reason why reactions with a high atom economy are used in industry. It's only because, to produce a higher percentage of a useful product. That is the reason why. Okay, right, this is all based on atom economy, and I'm not going to go through atom economy again, but I really hope you found it useful. Thank you. Okay then, so we are going to go through a practical exam question, and it is worth 4 marks. And let's go through question 2.3. A student is given 3 metals, X, Y, and Z, to identify. The metals are magnesium, iron, and copper. Plan an investigation to identify the 3 metals by comparing their reactions with dilute hydrochloric acid. Your plan should give valid results. Right, so the key steps that are involved, I've already written down the full model answer. So the key steps are to add the metals to hydrochloric acid, okay? Now, just to see, obviously, when we're testing their reactions, we could either measure the temperature change, or compare the rate of bubbling, or compare the colour of the resulting solution. So if you write down measure temperature change, that's perfectly fine. Or if you don't write that down and you write down compare rate of bubbling, that is perfectly fine. Or if you write down compare colour or resulting solution, that is perfectly fine too. So, I already know that magnesium is the most reactive, and what they've done in this question, they've actually given you the metals in order of reactivity. So magnesium is more reactive, so I'm going to put down 1 there, and then iron is a second reactive, and then obviously the least reactive is going to be copper. If you've looked at the reactivity of metals, you would already know this. So I wrote down for copper, which is over here, I'm going to zoom in. There is no reaction as there is no temperature change or no bubble. So you would have done this chemical reaction in school. I'm not sure if you have or not, but you'd see that when you react copper with hydrochloric acid, there is no such reaction because there's obviously no temperature change and there's no bubbles to, indicate there's a chemical reaction taking place, okay? And then you can write down for magnesium, there is a temperature change, obviously, because magnesium is quite reactive compared to copper and iron. And magnesium increases in temperature. So the more reactive it is, the more it does increase in temperature. And magnesium does increase in temperature more than iron, or magnesium bubbles faster than iron, or magnesium forms a colourless solution and iron forms a coloured solution. Okay, so if you write these points down, you will get the full marks, and in taking into account the control variable is what you keep the same to make it a fair test. So we use the same concentration, volume of hydrochloric acid, same mass of the metal. Just make sure that you do state the control variables because it does say your plan should give valid results. Okay? Right, so this will get you the full 4 marks, and it is based on a practical, and it's quite an easy question, I'll be very honest with you. And if you have done this practical, it is a bonus because you've obviously observed the reactions and you know what happens. I hope this model answer has helped you, and you can screenshot it if you like, and yeah, take care. Hello there everyone, I'm going to go through a calculation based on reacting masses. Now reacting masses is a very popular calculation. It does tend to come up every year. It's a very common calculation that comes up on the combined paper. So if you're doing combined, please make sure that you do watch this video, and it does come up on the chemistry triple paper too. Now, I've got a really easy two-step method on how to work out the answer for this calculation. In school, you probably have to work out the scale factor and you probably have to use ratios, but I promise you my method is very simple and easy. And a lot of students that I teach this method to, they actually think it's much better and easier to understand. So let me show you how to do this. So let me go through the question. Calculate the minimum mass in grams of magnesium. So I'm just going to highlight magnesium over here. Needed to completely reduce 1.2 kilograms of silicon dioxide. So I'm going to highlight that as well. Okay, so the first part, which is going to be step 1, we need to work out the number of moles. We need to initially work out the mass of magnesium, but in order for us to work out the mass of magnesium, we need to work out the number of moles first. Because when you're working out the mass, I'm just going to show you over here, mass equals moles times by the RFM, or relative atomic mass. So in order for us to work out the mass of magnesium, we need the number of moles. Hence why in step 1, we're going to work out the number of moles of the element or compound that we've been given the mass for. Now we can see that we've been given the mass for silicon dioxide and it's in kilograms, but you can see we want the answer in grams. So we convert from kilograms to grams by multiplying it by 1,000 and we're going to get 1,200. Make sure you know how to convert your units. So let's work out the number of moles. So moles equals the mass divided by the RFM of silicon dioxide. So we're going to do 1,200 divided by 60. That is the RFM of silicon dioxide, which I'm going to circle now in the equation that you can see over here. Okay. You should know how to work out the relative formula mass when you do reacting masses. So we do 1,200 divided by 60, and that is going to give me 20 moles. And that is it. That's all you have to do for step 1. So step 1 is complete. I'm just going to tick that over here. We've completed it. We're going to move on to step 2. So we can see that we need to work out the mass in grams for magnesium. So what we're going to do now, when we're working out the mass, we have to multiply the number of moles by the RFM of magnesium. So let me just write this down over here. When we're working out the mass, I'm going to write down the equation equals 20, which we already have. This is going to be the mass of magnesium. I'm just going to write that down over here. We're going to multiply that by the RFM of magnesium. Now we're going to find magnesium in the equation here. So we can see magnesium is over here, which I've just underlined, and we can see we've got a 2 in front. Now, what you're going to do is that you're going to multiply the relative atomic mass of magnesium, which is 24, by 2. A lot of students do say that you're not supposed to do this, but you can do it for my method and you will get the same answer. So I'm going to do 24 times by 2. And that's going to give me 48. And then we're going to get our answer as 960. And that is it. That is your answer. That is your 5 marks. That's all you need to do. This is my 2-step method on reacting masses. And I promise you, if you use my method, you will get these 5 marks. What I would advise you to do if you have previous past papers or any worksheets from school, use my method and just see how easy it is to get the answer. You don't have to do no ratios, scale factors. It's just confusing. This is 5 marks and I've just showed you how to do this calculation in 2 easy steps. I really hope that you have found this useful. And this topic is reacting masses. When you're doing reacting masses, you always need to refer to the equation, which we have over here. And you can multiply. When you're working at the relative formula mass, you can multiply it by the coefficient when it comes to my method for reacting masses. If you do have any questions on reacting masses, please do leave any comments and I'll be more than happy to help. Okay, good luck. Hello there everyone. I'm going to go through the topic which is going to be electrolysis because a lot of students do not understand this topic. So I'm going to go through the key points that you need to know prior to your exam. So here is the apparatus that we use for electrolysis. We have two electrodes. One is called the negative electrode and one is called the positive electrode. The negative electrode is called the cathode, which has a negative sign, and then we can see the positive electrode is called the anode, which has a positive sign. The best way to learn electrolysis to remember is to use the word panic. Positive anode, negative is cathode, okay? Right, so what we need to do is that we need to work out which ions are going to be present in sodium chloride. And we can see we've got aqueous written in brackets. That means it's dissolved in water. Now, when sodium chloride is dissolved in water, we need to also take into account that we have water in there, and water gives the ions H plus and hydroxide ions. A lot of students have asked me, how do I know sodium is plus? How do I know chlorine is minus? You need to memorize these charges. It's very important that you do memorize them. You can get them from the internet. You can get it from the BBC Bite Size website. If you do look online, it will give you the charges for each of the elements. Now, in sodium chloride aqueous solution, these are the ions that we're going to have. We're going to have H plus, sodium, Na, Cl minus, and OH, which is hydroxide. Now, we need to work out which one of these are going to be made at the cathode or the anode. So it's a bit like, obviously, a competition. So there is a rule that we need to remember that is at the cathode. Before we move on to anode, I'm going to go through cathode. So we can see we've got two pairs of negatively charged ions and two pairs of positively charged ions. Now, a lot of students say that sodium is going to be made at the cathode. It's not going to be hydrogen. So let me show you this rule over here. So at the cathode, whether hydrogen or a metal is produced at the cathode depends on the position of the metal in the metal reactivity series. The metal is produced at the cathode if it is less reactive than hydrogen. So any metals that are less reactive than hydrogen will be made at the cathode. So copper, silver, and gold will be made at the cathode if it's less reactive than hydrogen. Hydrogen is produced at the cathode if the metal is more reactive than hydrogen. So we can see that sodium is right here at the top. I'm just going to show you here. And then hydrogen is below sodium. So we can see over here, it says hydrogen is produced at the cathode if the metal is more reactive than hydrogen. And if that is the case, sodium is more reactive than hydrogen. So what's going to be made at the cathode is going to be hydrogen gas. So this one is going to be obviously made over here. Just remember, you need to know this rule for the cathode. Now, we're going to look at the anode now. So which one is going to be made at the anode? Is it going to be chlorine or is it going to be hydroxide ions? So there is a rule at the anode as well. So the order of discharge at the anode is halide ions. If there's a halide ion, then that will be made at the cathode. Or if there isn't, then if there's a hydroxide ions, then that gives out oxygen gas. And then obviously, if there's no hydroxide ions, if it's any other negative ions, then obviously that will be made at the anode. So we can clearly see over here that we have the chloride ion, which is a halogen. So this halogen over here is going to be discharged at the anode. Okay, so I'm going to cross that out. So this is how we basically work out what is going to be made at each electrode. Okay, so here we know for cathode it's going to be hydrogen gas, and then obviously at the anode it's going to be chlorine gas. Okay, so just make sure you remember the rule at the anode and the cathode, and I've got the order of discharge over here. It's very important for you to know about the reactivity series. You need to remember the reactivity series when it comes to electrolysis. Just remember chlorine, the negative ion, which is chlorine, bromine, iodide, chloride, bromide, iodide, sulfate. So we can see chloride gives us chlorine gas, bromide gives us bromine gas, iodide gives us iodine, and then we can see sulfate gives us oxygen. So make sure you do remember this as well over here. Okay, this is it for now on electrolysis. This is the basics of what I needed to go through with you. This is for aqueous solutions. Remember, we have the ions hydrogen and hydroxide, which I've just underlined over here. Right, what I'm going to do, I'm just going to quickly go through the electrolysis of aluminium oxide, okay? And this one is molten aluminium oxide. So this is going to be a bit different to aqueous solution. So here we have the formula for aluminium oxide, Al2O3. And the ions that are going to be present in this molten compound, when it's molten, we just say it's melted. It's not dissolved in water. So the ions that we have present, we have Al3 plus, and then we have oxygen 2 minus. Okay, so oxygen is going to be discharged at the anode, which we have over here, and then aluminium is going to be here at the cathode. Okay, and this is what you need to remember for the electrolysis of molten aluminium oxide. Right, what I'm going to do now is I'm just going to do a little example with you, another example. So let's say if we do the electrolysis of, one moment, potassium chloride, okay, and that is going to be aqueous, meaning it's dissolved in water. So which ions are going to be present? So we're going to have K plus ions, and then we're going to have chloride ions, which is minus, they're negatively charged. We're going to have hydrogen, which is positively charged, that comes from water, and then hydroxide, which is going to be negatively charged. So which one of these are going to be made at the cathode or the anode? So I know definitely that when we look at the reactivity series, potassium is right at the top. So we can see that potassium is more reactive than hydrogen. So that means potassium is not going to be made at the cathode, it's going to be hydrogen. So hydrogen is going to go over there. And then we can see that we have a halogen present. That's the order of preference or order of discharge at the anode. If there's a halide ion present, then that will be discharged at the anode, and that's going to be over here. Okay, I really hope that this has helped you. I am going to move on to half equations now. And let me just rub this out, everyone. Now, you will definitely be tested on half equations when it comes to electrolysis. And I promise you, these half equations are very simple. They're very easy. They're not that difficult. So what I'm going to do, I'm just going to start another video on half equations for electrolysis, and then we'll take it from there. Hello there. So we're going to do some half equations for electrolysis. So firstly, we're going to do the half equation for the reaction reduction. Now, reduction takes place at the cathode, and oxidation is the reaction that takes place at the anode. Okay, so let's start with reduction. Now, when we have to write up a half equation for reduction, the number of electrons that have been gained, because remember, we have oil rig, reduction is gain and oxidation is loss. Just remember these 2 points over here. So I'm going to show you how to write up the half equation. Now, you may be asked to write up the full equation, or you might be asked to fill in the missing blanks. It could be anything. So with reduction, the number of electrons that have been gained come before the arrow. So let's write up the half equation at the cathode, where we have the reaction, which is reduction. So we had used an example, which was sodium chloride, and aqueous, meaning it's dissolved in water. And these are the ions we have present. We know we have H plus ions, we have the hydroxide ions, and we have the sodium ions, and we have obviously the chloride ions. And we know that hydrogen is going to be made at the cathode, and obviously chlorine gas is going to be made at the anode. So let's write up the half equation for hydrogen, which is going to be made at the cathode. So what we're going to do, this is how you write it up. So I'm going to have H plus, the ion over here, and then the number of electrons that have been gained are going to come over here. And then remember, the number of electrons gained come before the arrow, not after the arrow. And here we have the hydrogen atom, the molecule. Okay, so what we need to first do when we're doing half equations, we need to balance on both sides. So we can see we've got 2 hydrogens over here, but we've got 1 there, so I'm going to put a 2 over there. So that's balanced on both sides. So now the next thing that we have to do is work out the charge. So this hydrogen, which we have over here on the right hand side, it has a 0 charge. There's nothing there at the top. but this one has a charge of +2. The reason it's +2 because I multiply the big 2 by the +1, that gives us +2. Now the rule is everything has to equal to the lowest number, which is going to be 0, which we can see here. So what do we do to +2 to make it equal to 0? We -2, so that's going to be 2e minus. So that is your half equation at the cathode, and the reaction that takes place at the cathode is going to be reduction, okay? And this is how you would do it. Now let's do the half equation, which is going to be at the anode. And we know that chlorine gas is going to be made at the anode. So let's start with this one over here. So when it comes to oxidation, the number of electrons that have been lost come after the arrow. So here we have the chloride ion over here, and then we have the chlorine atom, and the number of electrons that have been lost are going to come after the arrow. So first thing we do is balance it on both sides. So we look on both sides on the right and left if we got balanced number of chlorine. So we got 2 there, I'm going to put a 2 over there. And then we work out the charge over here, which is on the right hand side. We can see it's 0, and the charge over here is going to be -2, because you do the big 2 multiplied by the -1, it gives us -2. Now the rule is everything has to equal to the lowest number, which is going to be -2. So what do we do to 0 to make it equal to -2? We take away 2, so you put +2e minus. That's what we need to do, and this is how you do the half equation for the reaction oxidation. Okay, so I've gone through 2 examples with you, and these 2 examples that I've gone through with you, you would have to use the same technique for any other element. If it's potassium, if it's oxygen, aluminium, you use the same technique. Okay, I really hope that this has actually helped you. This is everything that I'm going to go through with you in terms of electrolysis. I am going to do some past paper exam questions with you next, just to make sure we can consolidate all your knowledge together. And please do leave any comments if there's anything that you didn't understand. Thank you. Okay, everyone, I'm going to go through some exam questions based on electrolysis. So let's do question 7.1. This question is about chemical reactions and electricity. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the processes in electrolysis and in a chemical cell. And that is worth 2 marks. So electrolysis uses electricity to produce a chemical reaction. However, cells use chemical reactions to produce electricity. And that is going to get you 2 marks. Okay? So tick this question. We've already done this one over here. Just make sure you memorize this. 7.2. A teacher demonstrates the electrolysis of molten lead bromide. When it's molten, it means it's melted. Bromine is produced at the positive electrode. The positive electrode is called the anode. I'm just going to write that down over here. And complete the half equation for the production of bromine. You should balance the half equation. So when it's the positive electrode, the reaction that takes place at the positive electrode is going to be oxidation, okay? And then oxidation is loss. So the number of electrons will come after the arrow, like I told you before. So over here, we're going to have the bromine molecule. And then after the arrow, we're going to have the number of electrons that we've lost. Firstly, we need to balance it. So on the right-hand side, we can see that we've got 2 bromines, but we've only got 1 bromide. So I'm going to put a 2 over there. Now it's balanced. On the right-hand side, there's no charge. That's going to be 0. However, on the left-hand side, we have a charge of -2, because we do the big 2 multiplied by the -1 gives us -2. Now, the rule is that everything needs to equal to -2. So what do we do to 0 to make it equal to -2? We take away 2, so we're going to have +2e minus, and this is how you would complete a half equation. And this is just a typical example of an exam question that you could possibly get in your exam. Okay, now let's go for 7.3. I'm just going to zoom in a little bit. 2 aqueous salt solutions are electrolyzed using inert electrodes. Inert means it doesn't react with anything. Complete table 4 to show the product at each electrode. So let's start with copper nitrate solution, meaning it's dissolved in water. So here's the formula for copper nitrate. We need to basically work out which ions are present in copper nitrate. So we're going to have copper, and we are going to have nitrate ions. This is the charge for nitrate. And we're going to also have hydrogen ions, because remember it's dissolved in water. And we're going to have hydroxide ions as well. Okay, so we've got 2 pairs of negatively charged ions and positively charged ions. Okay, So we need to work out which one is going to be made at the positive electrode, which is the anode. So we already know that copper is made at a negative electrode, which is called the cathode. And the reason it's copper is because copper is less reactive than hydrogen. So the rule is if the metal is less reactive than hydrogen, then that metal will be made at the negative electrode, which is the cathode. Now we need to work out what product is going to be made at the positive electrode, which is going to be the anode. So remember the rule at the anode. I said if there is a halide present, then that halide will be made at the positive electrode, but there's no halide present. Can't see any halogens, so we can move on to the next one. If there's any hydroxide ion, that will give us oxygen gas. So we can see we have a hydroxide ion here, and that is going to give us oxygen gas. I'm going to write down oxygen over here. Okay, and then let's look at potassium iodide, the ions that are going to be present. We're going to have potassium, we're going to have hydrogen, again it's dissolved in water, we're going to have hydroxide, and then we're going to have iodide. Okay, so which one of these is going to be made at the cathode and the anode? So let's start with the negative electrode, which is the cathode. So I know we're going to have hydrogen over here. It's not going to be potassium because potassium is too reactive. It's further up in the reactivity series, and according to the rule at the cathode, if the metal is more reactive than hydrogen, then hydrogen will be made at the cathode, which we can see over here. And then which product is going to be made at the positive electrode, which is the anode, and that's going to be iodine. Okay, so I'm just going to write that over here. Remember the rule at the anode, if there's a halogen present, then that will be preferred first at the positive electrode, which is the anode. Right, I really hope that these exam questions have helped you. I do apologize that I've not gone through a lot of exam questions, but I'm trying my best, everyone. And I'm just going to change my answer over here. I've put down H+. You are meant to write down hydrogen over here. So I'm just going to write hydrogen over here. And you can see that is going to be your answer. So oxygen, iodine, and hydrogen. Right, I really hope this has helped you, and please make sure you remember your charges for each of the ions and elements, obviously. Okay, everyone, good luck in your exam. Okay there, so I'm going to go through another exam question, which is to do with structure and bonding for simple molecules. So let's go through question 5.1. This question is about ammonia, NH3. Complete the dot and cross diagram for the ammonia molecule shown in figure 6. Show only the electrons in the outer shell of each atom. So I know that this is going to have covalent bonding because covalent bonding happens between two nonmetals, and nitrogen is a nonmetal and hydrogen is a nonmetal. And in covalent bonding, we are sharing electrons, okay? Now, make sure that you do use your data sheet, which is your periodic table in your exam, to help you to work out the number of electrons in the outermost shell. So basically, I know that nitrogen is in group 5, so it has 5 electrons in its outermost shell. So this is how I would arrange the electrons. I'm going to show you now. So I'm going to represent it with a cross. So top, bottom, right, and left. And now again, top. Okay, so now we've got 5 electrons in the outermost shell for nitrogen. And I know that hydrogen has only 1 electron in its outermost shell, and that's going to be represented by a dot, which I'm going to do with a different color. So here we have 1 electron over here, and then 1 over here, and then the other one over here. So now we can see that because we're sharing electrons, nitrogen has a full outer shell. It's got 8 electrons in its outermost shell, and then obviously hydrogen has 2 electrons in its outermost shell, so it's stable. Okay, so this is how you would do the dot and cross diagram for covalent bonding. And remember, in covalent bonding, we are sharing electrons. We are not transferring them over. So we are sharing electrons to achieve a full outer shell. Right, 5.2. Give one limitation of using a dot and cross diagram to represent an ammonia molecule. So we can write down it's only 2-dimensional, and that's 1 mark. Next question is 5.3. Explain why ammonia has a low boiling point. Now, ammonia is a simple molecule, okay? So I'm just going to write that down over here, simple molecule. And There are other type of simple molecules such as methane as well and water, but in this example we've been given ammonia. Let's say if you were given methane, obviously you'd have the same answer. So let's look at what the question is asking us. Explain why ammonia has a low boiling point. You should refer to structure and bonding in your answer. So first thing I'm going to write down is a very small molecule. It's a simple molecule, so it's a very small. Has very weak intermolecular forces of attraction, and therefore little energy is needed to overcome the intermolecular forces. Let's say, for example, if you were asked, explain why methane has a low boiling point, you would write the same answer. Okay, so this will get you 3 marks over here. Small molecule, weak intermolecular forces of attraction, little energy is needed to overcome the intermolecular forces. Okay, I really hope that this has helped you in terms of structure and bonding. And again, if you do have any questions, please do leave them in the comments and I'll be more than happy to help. Thank you.